Hi ladies, I hope you've been enjoying your snow. I have certainly gotten my workouts in with shoveling. Okay, so I've attached some notes on stopping distance. Previously, we have worked with connecting momentum and impulse. Now we are adding in a new piece, a new component, where we're going to calculate stopping distance. In order to calculate stopping distance, we're going to actually use the kinematic equations. I know, don't all start crying at once. First, look at my notes. There are two scenarios, maximum momentum and least amount of momentum, which the least amount of momentum should be 0. Review these notes, and I will answer any questions and explain them briefly when I get back. But make sure to pay attention to the different scenarios and the different examples, especially the airbag example. Pay close attention to that one. Okay, the sample problem says a 2,240 kilogram car traveling to the west slows down uniformly from 20 meters per second to 5 meters per second. How long does it take the car to decelerate if the force on the car is 8,410 newtons to the east? How far does the car travel during the deceleration? So a few things to note here. 1. The car is traveling to the west. What does west mean? Who wants to answer that question? Oh, you do. West means to the negative. Okay, so the velocities are going to be negative. And the force is to the east. What does the east mean? The east means that we're going to be positive. Okay, from there, you want to calculate two things. The first thing you want to calculate is how long does it take to decelerate? So you're finding time. And then from there, you're going to calculate how far the car travels when it's decelerating. For the second part, how far, that's where you're going to use a kinematic equation. Now look at the problem I did in class before our snow. The first part of the problem wants you to calculate time, the time it takes to stop. If you do it like I've done for you on the board here, you will see that it should come out to be 4 seconds. From there, you are now going to want to use that time and the initial and final velocities to calculate delta x. You will use the first kinematic equation. Delta x is equal to 1/2 parentheses vi plus vf end parentheses times time. You want to use this equation because you don't have acceleration, and all the other equations use acceleration. You should get, for delta x, negative 50 meters. It's negative because it's to the west. Try this sample problem on your own. To give you a hint, the 4 kinematic equations are over to the right on this screen. Once you have finished the sample problem on your own and you've gotten the correct answers, you will do sample problem C, numbers 1 and 2, on your own. I have given you some hints on this screen in green in the middle. I will be available through email if you have any questions about any of the problems, and I will gladly answer it. I'm around all day tomorrow. That's it for now, ladies. Remember, try those sample problems. If you have any questions, email me and I'll gladly answer any questions. These will be due the day we get back, the next day I see you. No questions asked. If you have any questions, you need to come and see me about it or email me and I will answer all questions. Have a great rest of your snow days.